Hi, Pre-Calc. This is Hyperbolas Day 3. It's actually the last new lesson, kind of-ish, in conic sections. The most part of what we have left is review materials. There might be a couple new last-minute things that we have to add in, but this is pretty much the grand finale here. It's going to be a quick lesson, too. There's one practice sketch here that I'd like you to try, where you're going to complete the square, get it into standard form, identify all the key coordinates, asymptotes, things like that, and then make a sketch of it. So go ahead and try that at the start. And the only other new thing we have to add on is, of course, the process of working backwards. If I gave you some information about a hyperbola, could you come up with the equation of the hyperbola? So if you've already tried it and you've hit pause and you're ready to check out some answers, here's what I have just for the completing the square and for the key info. So I grouped the x's, grouped the y's, completed the square for the x's and y's. Just make sure whatever you add here, you add 4 times 9 on this side. A little bit weird that what you're taking out as a GCF is -1 to complete the square there, so I hope that was okay. But when I add 9, I really added -9. Okay, so you got to subtract 9 from this side. So then go ahead and rewrite it in that factored form. When you divide by 9, 9 over 9, I would probably leave it as over 1 just so that you know the value of a is 1 there. Okay, and then this would stay over 9. And yeah, I mean, it's a little bit different looking than some of the other examples when you compare it to what we've seen in class and on the homework. So hopefully that went okay for you. If not, I hope it makes sense now. Here is all of the info that you would ever want to know about this hyperbola. The vertices, the ends of the conjugate axis, foci. I did the LR length over here. It had a nice length of 18. So therefore, the ends of the LR look like this. And then the last thing that we've got here are some asymptotes. Okay, the asymptotes, make sure that when you're taking a look at the graph, in this case it was the ratio of b over a for the slope, and it has to go through the center. So if we're pretty good with that, oh, by the way, if you want to see the graph, I have some graph paper here. Here's what the graph of that hyperbola looks like. It opens up super wide because this box right here is a lot more narrow than what we're used to seeing for when we have to draw on those asymptotes. Okay. If it had opened up and down, you actually would have seen something that was very narrow in that case, okay? So if you look at the bottom section, we have 4 really quick questions about working backwards to write the equation of a hyperbola that has this given information. So what do we know for the first example? We know that the center is at 0, 2. The transverse axis is along the y-axis, okay? Transverse axis, as a reminder, is the one that connects V to V prime. We've got the one focus and one vertex. Okay, so here's what we've got. We've got the center here, 0, 2. We've got a vertex, 0, 6. We've got a focus, 0, 10. Even though I don't have graph paper right now that I'm working on to do this, I think just pre-planning out right on, just drawing a rough sketch off to the side, best case scenario when you're doing questions like this. Okay, what do I need to know to write the equation of hyperbola? I need to know the center. I need to know the values of a and b. And I need to know which way is it opening. Is it horizontal or is it vertical, which happens to be the same exact information that we needed when we wrote the equation of an ellipse. Same critical info there. All right, so the center at 0, 2, that's going to be important. We have the distance from the center to the vertex. That from 2 to 6 is going to be a distance of 4, and we know that that's a. From center to focus has a length of 6. No, hold on, sorry. From 2 to 10, it's going to be a length of 8. So that's the length of C. So if we have A and we have C, how on earth am I going to find B? Oh yeah, it's that good old Pythagorean relationship. Just make sure we're using the correct one. For a hyperbola, it's C squared equals A squared plus B squared. So you got 64 equals A squared, which is 16, plus B squared. Subtract 16 to the other side, you get that 48 equals b squared. And even though that implies that b is the square root of 48, just like I did for ellipses, I usually actually stop there and then use that value because b squared goes in the denominators. So when I say that I need a and b up here, it's actually really that we need a squared and b squared, isn't it? Okay, so I know b squared is 48. I know that a squared is 16. And the last thing we really have to think about is which way does this open? We haven't talked about that, horizontal or vertical. Well, based on the fact that the focus is above that vertex there, it's going to have to open up, and then we'd probably have a matching one down here somewhere that opened down. So it's a vertical hyperbola, which means that y squared comes first. So with the center coordinate, if y comes first, you're going to do y minus 2 squared. In a hyperbola, a squared is always in the first denominator, so that's going to be 16. Minus, you don't really have to write x minus 0 squared, you can just write x squared over b squared, 48. Don't forget to set it equal to 1, and then you're done. Okay, that's the answer to number 1. Now, I went through that quickly. There's actually a lot of moving parts to that, right? I mean, there's a lot to think about when you're saying, okay, it's vertical, which means y comes first, which means take the y value of the center. A squared is always the first denominator. You know, if you've really been doing a nice job sketching over the past few days, I hope that information's pretty readily available to you. What have we got in number 2? Number 2, we have a center at the origin. I always like when the center is the origin. That makes things nice and easy. The transverse axis is of length 12, and it's along the y-axis. So what did I say about the transverse axis over here? By the way, we never actually really even needed or used that fact in number 1. Notice how I never came back to that? Okay, it actually, with where the vertex and center and focus were located, I didn't need that piece of info. We do need it for number 2, though, because we don't have enough info otherwise. The transverse axis of length 12, the way I'm going to use that is that if it connects V and V prime, I know it has a length of 2a. So if the total transverse axis is 12, that means a is 6. It's along the y-axis, so I don't even think I need the sketch here. I can kind of steal this graph. If the transverse axis, V and V prime, are along the y-axis, that means this one's vertical as well. It's going to open up and down because of that being along the y-axis part. So we know it's vertical. We know A is 6. We know the center. We just got to find B. We know the length of the LR is 6. So what's the length of the LR in general? It's 2b squared over A. Oh, but A in this example is 6. So instead of writing 2b squared over A, I'm just going to write 2b squared over 6 equals the length of the LR, which also is 6. So just don't get confused that these are both 6s here. A is 6, and then the length total has to equal 6. So if you multiply both sides by that 6, you get 2b squared equals 36, and therefore b squared is 18. We know b squared. We would know a squared is 36. We know it's vertical. We've got all the pieces. So when I write the equation here, it's going to be y squared over a squared, which is 36, minus x squared over b squared, 18, equals 1, and then I'm done. Okay. So center 0, 0, again, those numerators are, you know, sort of tough to mess up other than the fact that we needed y to come first. So just be careful with that. All right. Continuing on from here, we've got a center at -2, 2 given, a vertex, a focus, transverse parallel to the x-axis. Okay. Center at -2, 2. Let's see if we can get a rough sketch here. So -2, 2, let's say that's over here. The vertex is at 4, 2, and the focus is at 6, 2. That transverse axis being parallel to the x-axis, I don't even really need that because I can tell that the vertices are going to be going left and right of the center. So it's fine that they gave that info to me, but again, just like in number 1, that last piece of info wasn't really necessary. I already know based on where the vertex and focus are located that this is going to open up to the left and to the right. So it's horizontal. All right, we know it's horizontal. We know the coordinates of the center at -2, 2. We know the value of A because center to vertex is A. In this case, that's a distance of 6. Center to focus in this one, C, is going to have a distance of 8. So really similar to what I did up here. It's almost the same type of question, right? Given center, vertex, focus, just that it's opening left and right this time. All right, so what am I going to do this time? I'm going to do c squared equals a squared plus b squared. So 64 would equal 36 plus b squared. If I subtract the 36 over, that should be 28 equals b squared. And that's good for, we don't have to go any further with that, right? We know b squared, we know a squared, and we know it's horizontal. So if it's horizontal, x comes first, so it's going to be x plus 2 squared over a squared, which is 36, minus y minus 2 squared over 28 is equal to 1. Okay, one more to go, and that's it for practice with working backwards. Okay, center at 2, -2, almost the same as this one. Transverse of length 6, parallel to the x-axis. Conjugate axis has length 10. Okay, transverse axis with a given length. We just did that number 2. Transverse total is 2a. So if 2a equals 6, then a is 3. We also know the length of the conjugate axis. Conjugate connects b and b prime. So that's going to be a length of 2b. If 2b equals 10, then b is 5. All right, we've got a, we've got b, we've got the center. And the last thing I have to know is which way does this open, and if the transverse axis, the one that connects the vertices, is parallel to the x-axis, just like this one was, then the last thing I have to know is that this is also horizontal. It's going to open up to the left and to the right. Okay, with all those pieces put together, the equation will be x minus 2 squared over a squared, and this one is 9, minus y plus 2 squared over b squared, which is 25, equals 1, if I can squeeze that in there. Okay, and there you have it. So you'll see, I hope, very similar looking information when you go to try the homework on this and the rest of this unit, even though there might be a little bit, just some additional info thrown your way. This is pretty much it for all of conic sections. Okay, so let me know if you have any questions. The next stuff you'll see is just lots of review.